Hello, geometers. I would like to talk to you a little more about inductive and deductive reasoning. Inductive reasoning is what we get when we work from a broad amount of data to form a conclusion. You might do this sort of thing when you are writing an essay and your teacher says, support your thesis by giving examples. And your examples should support your conclusion. Now, is there a hard connection between your data and your conclusion? Perhaps, perhaps not. But this is the process of inductive reasoning. You want to gather your data up and bring your readers or your whoever you are, your audience, to a conclusion that you have formed. In deductive reasoning, we work from known facts or premises and a logical flow to form a conclusion that we can test to see if it's true or false. And these facts or premises, in order for the conclusion to be true, the facts or premises likely both have to be true as well. And if one of them's true and the other one's false, then you're going to get an invalid conclusion. And if they're both false, you might end up with a true conclusion. Anyway, we'll look more at that in a future lesson. Here are some examples of good inductive reasoning. For instance, there is a high pressure system stuck overhead, so the weather tomorrow will be sunny. Predicting the weather is by and large an inductive process. We look at lots of patterns, we know what those patterns will conclude for us or a particular location on a particular time, and then we begin to predict the weather. But as you know, the weather prediction is not always accurate. Here's another one. The victim died from multiple stab wounds. Mike's fingerprints were the only fingerprints found on the bloody knife at the murder scene. Mike had probable cause to commit murder because the victim tried to blackmail Mike. Therefore, Mike committed the murder. Well, we have a weapon, we have a motive, and we have a perpetrator. And whether you decide that all this leads to a conclusion that Mike committed the murder, well, it might depend on whether you're on the jury or not. So we often give jury the directions that if you know beyond a shadow of a reasonable doubt that Mike did this, then you will deliver a guilty verdict. But if you have any reasonable doubt in your mind about this, then you will deliver a not guilty verdict. So that's another example of inductive reasoning. Here are some examples of some pretty bad inductive reasoning. Everyone says eating spinach is good for you, so if I eat lots of spinach, I will be good. Well, okay. Spinach might be good for you, but in large quantities, spinach might not be good for you. And the other thing is this everyone says stuff. That's an example of inductive reasoning that's pretty bad. Everyone says, or everyone's doing it. 9 million people can't be wrong. Those are inductive reasonings that are inductive. That's an example of inductive reasoning that may or may not lead to a good conclusion. Here's another one. I can't have cancer. I only eat organic foods and run 3 miles every day. So if you do everything you can to support your health or to have good health, does that mean you will never get sick? Well, this is a case of inductive reasoning leading to a pretty poor conclusion, and actually it's pretty poor inductive reasoning. Here's an example of some deductive reasoning. These are deductive reasonings that lead to valid conclusions. All squares are rectangles. All rectangles are quadrilaterals. Therefore, all squares are quadrilaterals. You notice that we start with squares, we lead directly to rectangles. We pick up with rectangles, we lead directly to quadrilaterals. And then we can connect the first thing, squares, with the last thing, quadrilaterals. Therefore, all squares are quadrilaterals. So this is a fact, this first sentence, all squares are rectangles. The second sentence is also a fact, all rectangles are quadrilaterals. And then the third sentence is one that can be deduced from the first two sentences. Here's another example of good deductive reasoning. The murderer had to be present at the time of the murder. Mike was on a flight to Europe when the murder was committed. Therefore, Mike did not commit the murder. So this is another example. Even though we might use inductive reasoning to decide whether somebody is guilty or innocent, we might use deductive reasoning to decide what did not happen. And this is an example of deductive reasoning. That would be evidence maybe against Mike's being the murderer. Here are some examples, some invalid examples of deductive reasoning. The light bulb is good. If I flip the switch, the light will come on. Well, what's missing here is some premises that are in between what we start with and what we end with. The light bulb might indeed be good. If you flip the switch, the process here starts with flipping the switch. Well, what must be true if you flip the switch? You might have to check the switch to make sure that the switch works. You might have to check to make sure that there's electricity supplied to your circuit. You might have to check to see if there's enough electricity or the right amount of electricity that's flowing through your circuit. And then if your light bulb is good, then your light will come on. So the reason this is an example of invalid deductive reasoning is because some of the links in your chain are missing. Here's another one. All dancers are tall and slender. Marnie is tall and slender. Therefore, Marnie is a dancer. Well, this thing kind of zigzags to a conclusion and commits what we'll call the converse error, meaning you're starting with dancers and you're concluding with dancers. And what you should have said maybe was tall and slender people are all dancers, but that might not be true. Marnie is tall and slender, but if that were true, and then Marnie being tall and slender, then Marnie might be a dancer. But this one does not work because we've got a converse error here. We've got an error in our logic here. Now, here's the curious thing, is that inductive and deductive reasoning can be used together. Inductive reasoning can be used to develop a rule. So here's some data I collected, and look at that nice line that falls in. And what I suspect is that there is a rule in here. And if I could figure out what the rule is, then I might be able to use that rule deductively to figure out what would happen at this mark right here, 38 or 40. I might be able to figure out what circle ought to be there at 38 or 40. And so we use inductive reasoning. We gather all kinds of data, and look at this. All this data might point to a conclusion. And then we can use our conclusion to predict. Again, that's inductive reasoning. But if it works, and it works every time, then that would be a deductive rule. Galileo predicted that objects dropped from a certain height would all hit the ground at the same time. And he didn't have a way to check starts and finishes. He could drop two objects at the same time and go, oh yeah, they're more or less hitting the ground at the same time. But he didn't have cameras, and he didn't have a lot of technology to prove that. And then he also worked out the rule for how fast an object is falling and how far it should be, or how long an object has been falling and when it should hit the ground. He worked out that rule. And that's an example where he said, I think there's a pattern in here somewhere. So he thought inductively to the pattern, and then he tested that and realized, hey, this is a rule. And now I can take this rule and apply it to another scenario, and that would be deductive reasoning. So I hope that helps in trying to define inductive, or help you understand the difference between inductive and deductive reasoning.